Okay guys, so we're just going to continue our journey here of solving log equations. Let's pick up kind of where we left off yesterday. You don't need to write this, but I just want to refresh where we were at, right? So let's say we had this, right? What we said to do yesterday was to exponentiate both sides, which means that you take this base here and you make that the base and this the power of that. And you do the same thing on the other side. My base is 3 and you make this the power. And then we're using one of our log properties to have these cancel, and we end up with the fact that x is 3 to the 4th power, which is 81. Okay, so that's what we learned yesterday. I want you guys to see if you could do this for me, though, really quick. ln of x is equal to 2. I want you guys to see if you could find me the answer for that one. I'll give you a second. Okay, cool. So what Nicole remembered is that the base for ln is e, right? So when we exponentiate both sides, we're going to use a base of e. So it's going to look like this. There's my base. That's going to be the power. And we're going to put the base again with that power, right? And then what we can do from there is the e cancels the ln, right? And so my final answer would just be e squared, right? So keep that in mind. Now, I mean, you could go further with this if you want to get a calculator out and actually get a decimal answer for what e squared is, but that's the idea there. All right, so we're going to take that foundation that we had from last class and we're going to build on it a little bit. Let's go ahead and begin example 1 here. All right. Let's see. Okay, so this is a new type of problem. Remember, we're going to call this how to work. This is how do you deal with numbers outside the log. How to deal with numbers outside of the log. So remember, a log is a function. Okay, so you know when we type these things into our calculator, we put parentheses, right? You're basically plugging that number into a logarithm. It's like it's doing something to that number. But in this case, the only thing that's being plugged into the log is this x. Okay? And this is a good time to talk about some notation too before we begin. And I would encourage you guys to write this down. Okay, so this is not the same thing as this. Okay? The difference is that on this thing, they don't write the parentheses, but if they did, it would look like this. Okay? But they're not going to put the parentheses. I want you to be aware of that. So if they don't have parentheses, then whatever's right next to the log is all that's in the log. So in this case, just the x is in the log. Just the x is the argument. Whereas over here, since they're using parentheses, the argument is not just x. The argument is x minus 3. So that's what's being plugged into the log. It's kind of like this. Can you guys, you don't need to write this, but you guys agree that you see a pretty significant difference between these two expressions, I would hope, right? There's a big difference there. There's a difference between squaring a number and then subtracting 3, and subtracting 3 and then squaring it. You'll get very different answers. Well, the same thing applies with logarithms. Oops, I did not want to erase that much. Hold on. Go backwards. There is a difference between taking the log of a number and then subtracting 3 from it, as opposed to subtracting 3 from a number and then taking the log of it. So those are different expressions, okay? And I wish that they would write it like this, but they don't. So you just have to know when there's no parentheses, it's just the thing that's right next to the log being multiplied. So there you have it. So that being said, we're going to start looking at some equations where we talk about how do you deal with numbers that are outside of the log. So for instance, numbers that are outside the log here would be the 2 and the 3. The only thing that's really in the log function is the x, okay? So how you deal with that is basically you get rid of those numbers first. So I would add 3 first to both sides like this. And then I would divide both sides by 2, like this. Once you've gotten rid of those outside numbers, the problem looks just like what we did last time, okay? So what you do is we're going to exponentiate both sides now to get rid of the log, right? So what base am I going to use? 10. When they don't write the base, your base is 10. And I'm just going to leave my answer as 7 over 2, 10 to the 7 halves power. That's good enough. Okay? Okay, let's take a look at another one real quick. So number 2, suppose I have that, right? Okay, so what would be the first thing I do? Okay, minus 4 on both sides. And then what? 5. And so now I'm left with ln of x equals 1, right? So I'm going to exponentiate both sides. What's my base? E. These cancel. X is equal to e to the first power, which is just e. Okay? Yeah. All right. So basically, how do we deal with outside numbers then? Just get rid of them first. Subtract, add, divide, or multiply if it's a fraction in the front. 1 more. All right, can I proceed? All right. So student practice time. Let you guys try one of these. Ready? So let's go through it here. Nylad, what did you get? You want to take a guess? It's okay if you're wrong. I can still give you points. I just want to see what you got. You don't have to if you're uncomfortable, but nobody's judging you. dye your hair? It looks good. I like it. All right. Steve, what did you get? Yeah, just the final answer. Okay, that is true. So Steve got this. Now, before you guys get upset, this is also the answer. They're the same thing. They're the same thing. Okay. Now let's see why that is. So we should have started by adding 3, right? Then we should have divided by -5, right? And then when you exponentiate both sides, which means you're going to make this a power on 2, and you're going to make this a power of 2, these cancel, and you're left with what most of you guys probably got. You can leave it like that if you want to. I didn't want to do my 10 to the 7/2 power just because it's just not really worth it. And honestly, I know how the software I work with works, and they will leave it like that too. Now, when it comes to something smaller like this, I'm not sure. They might actually go further because it's kind of, just square the 2 and put it in the bottom, right? So they might go that extra step. I don't know, but there it is. Let's see. 1, 2. This one, right? This one. I don't know. I got to back up. It's hard for me to know what this second step is. Where I started the green. Oh, the exponentiating? Okay. So we had this, right? And what we do is we exponentiate. What's the opposite? Kind of like here, like what's the opposite of subtraction? It's addition. That's how we get rid of it. What's the opposite of multiplication? It's division. That's how we get rid of it. What's the opposite of a log? No. What's the opposite of logarithms? The inverse of a logarithm. Exponents, right? So we exponentiate it. So what we do is we take this base and make that its exponent. Well, that's what the green was. I just made it a different color. But yes, I was lazy. I didn't show the whole thing. And then they cancel each other out. You got something? No. All right. So let's look at another type of problem. How to deal with numbers inside the log. So we've learned how to deal with numbers outside the log. How about dealing with numbers inside the log? So for instance, suppose I had this. -2 log base 3 of 4x minus 1 plus 3 equals, let's say, 5. All right, so here's what we're going to do. We have some inside numbers, right? I've got numbers inside the logarithm now with the x. It's more than just an x now inside the log. Now there's more in there. But we still have outside numbers. So the rule for that is still the same. Get rid of those numbers first. So I'm still going to subtract the 3 first. Two, right? And then I'm still going to do what next? Divide by -2. Okay, now here's where things get a little bit different though, right? And yet actually they're not different. What do I want to do now? I want to get rid of the logarithm. You can't touch this stuff here. Underline it. You can't touch any of those numbers until you get rid of the log. It's like a prison guard watching over them. So you got to get rid of that log before you can start dealing with the 4 and the 1. So how do you get rid of the log? Yeah, you exponentiate it, right, with the base of 3. It's okay. Thank you. Right? So now this is gone, right? And now the 4x minus 1 is free because you got rid of the log. All right. Yeah. Want to ask a question? So we're not done. We still need to solve for x. Now, here's the thing. You could do what Steve did, and you could change this into what? 1/3 if you want. But I don't want to get into all that stuff. I don't think they're going to give us problems like that anyway. I'm just going to leave it as 3 to the negative 1, if that's okay with you guys. Okay. So if I want to solve for x, though, what would I do? We're going to add 1 to both sides. The reason why I don't want to change it is just because then we're going to have a fraction and we're going to have to worry about that whole nightmare. And quite honestly, I'm just not real interested in getting into that right now. I don't want to lose you guys. I want to focus just on the logs. I don't want fractions to distract us. So the first thing we're going to do is add the 1. And then what am I going to do? Divide by 4. And I think I'm just going to leave my answer like that. Now, most of the ones on your guys' homework, you're not going to end up with funny-looking exponents like this. So you won't end up with funny-looking answers like this. Now, there is an exception. You will end up with funny-looking answers when you're dealing with e. And the reason for that is because they're just going to leave it as e with power. So you're going to have, it'll look weird like that. But when you're dealing with just numbers, my software pretty much makes questions that don't turn out weird like that, just so you know. But we could have done the work. You know, we could have changed this into a fraction, added 1 to it with a common denominator, and then divided that by 4 and got to a nice simple fraction answer. But I'm going to leave it like that for now. All right, so let me throw 2 problems at you guys here, see how you do with them. So student practice 2. How's about 2 log base 3 of x minus 1 equals 4. And then number 2, how about ln yes, I just of 2x minus 1 equals 3. All right, let's see if you guys can get those. Now, if I'm not mistaken, I think I set number 1 up so that you could actually get a pretty nice looking answer. You can leave it weird looking if you want, but you could actually get that one to come out to a nice normal number. But number 2, it's going to look weird like the one I had because it's got an e in there. So go. Like that? I think you're close. Let's see. You got 3 to the second minus 1? Okay. Let's see. Plus 1, and you'll be good. So let's see why. So first of all, we divide both sides by 2, right? Oops. And then we exponentiate both sides. Cancel those off. Now John chose to leave his like this. And then he added 1 on both sides, which is fine. However, I think on the test they would probably just do that 3 squared and make it a 9, because that's a simple one, kind of straightforward. And you would eventually you'd just get 10, right? All right, so let's go ahead and take a look at the next one there. How about Andrew? What'd you get for number 2?
E
minus 1 over 2. I'm trying to do that mentally. Hold on. E cubed. I think it's plus 1 over 2. What do you guys think? Okay, so let's see why. So first of all, but good job, Andrew. So there's no outside numbers here. So we would start by exponentiating to get rid of the log. That's it. So that cancels. And so what you're going to do now, oops. What you're going to do now is you're going to add 1 to both sides and divide 2 to both sides. So there you go. So e cubed plus 1 over 2.
So we don't change e to its point, like 2 point whatever?
No, they won't do that on the test. You could do that technically, but I know on the software I use, they're just going to leave it as e. All right, let's go ahead and take a look at some other problems. So we've learned three things about logarithms here so far, right? So let's just kind of review types of equations we've looked at. We've looked at these where you have a log on both sides, right? What do you do with that? Just drop it off, right? We've learned now about how do you deal with a log on one side. You exponentiate to get rid of the log, right? And then with this type of logarithm, we learned 2 specific things. We've learned numbers outside, and we've also learned how to deal with numbers inside. So the rule with numbers outside is do that first. The rule with numbers inside is get rid of those after you exponentiate. Okay, so that's kind of what we got so far. Now we're going to pull in some other stuff here. We're going to pull in some more log properties to the process here. So let's take a look at example 3. This will probably be where we stop after this example. This is where I'm going to start expecting you guys to do good with your algebra. Okay? So here we go. Log base 9 of 2x plus log base 9 of 6 equals 2. So what's weird about this one? We have 2 logs on one side. So how the heck are we going to deal with that? Well, maybe the first thing you might think is we'll put the log on the other side so you can cross them off. But the problem is that 2's in the way. It has to be just a log on this side and just a log on that side. So that 2 is in the way. So that's not going to work. So, but we've learned a property. Yeah, we've learned a property where if we have 2 logs that are being added together, how can I put those 2 logs together? Yep. You can turn them into 1 log if you multiply them, right? So that's what we're going to do. I can combine these 2 logs if I'm willing to multiply those arguments together. So what is 2x times 6? 12x. Okay? So after that, there's really nothing else new. Yep. Now we're ready to exponentiate. So what's my base here going to be? Is 9, right? 9 log base 9 of 12x equals 9 to the 2nd power. Cross it off. 12x equals what? Yeah, 81. We can do that. That's not a hard one to do. And then finally just divide, right? I believe this can be reduced. I know 3 goes into both of those. So 3 goes in there 27 times, and 3 goes into 12 4 times. So there's our final answer. All right. before I let you guys practice, though, I want to show you one more. And this one will be a little bit trickier. Not much trickier, but a little bit. Can you proceed? All right, so 2, let's take a look at that one. How about log base 5 of x plus 6 minus log base 5 of x equals I don't like that. Hold on a second. No, Mr. Bailey. No. Sorry. 2. There we go. Okay, so what are we going to do here? Yeah, remember, so we can put those 2 logs together if we're willing to divide the argument, right? So here's our property. If you have 2 logs that are being subtracted, we learned a little while back, you can write that as 1 log where they're being divided, right? So that's the rule we're going to apply here. And you got to remember the order matters. So whichever one comes first is the one that goes on top, and the one that comes second goes on the bottom. So this is going to be log base 5 of x plus 6 over x. The answer is 1/4? Okay, what do I do now? We're going to exponentiate, right? Since all I have is an inside part, right? We talked about inside stuff. You can't do anything with inside stuff till you get rid of the log, right? So we're going to exponentiate. So basically do the properties and then exponentiate. That's kind of the process. So it's going to be 5 and then 5. These cancel. And what's that going to equal now? 25. We could do that. That's pretty simple. We can handle that. 25. Okay, so here's where the problem might get a little bit weird for you guys. So any suggestions here about how we would solve this? That's right. Anytime you get a denominator, you don't like it, just multiply everything by the denominator, right? So I'm going to multiply this side by x, and I'm going to multiply this side by x. And when I multiply this side by x, the x's cancel, right? So we have x plus 6 then is equal to 25x. So there's 2 things I want you guys, before I go any further, there's 2 things you guys I want to sharpen your mind with real quick. Okay, I'll come back in just a second. So subtraction becomes division. That's the first big takeaway. The second big takeaway is, how do you get rid of that bottom? You multiply. The rest of it's pretty much stuff we've just been doing. So at this point, how do I solve for x? Yep, you want to put your x's together, right? So what is 25x take away 1x? 24. And then we divide. So 6 over 24 is 1/4, like Kondaker said earlier, 1/4. Okay. I wanted to get to quadratic stuff, but we don't have time. So I'm gonna let you guys practice this, but that'll be it after you guys do your student practice. I'll call. All right. So let's see. Student practice. What are we on? 3 or 4? 3. Okay. So All right. So we have log base 2 of 6 over x would be the first thing you'd want to do for number 1. Then you would want to exponentiate both sides. Yes, 2 to the third. These cancel and you're left with 6 over x equals 8. Multiplying both sides by x would give you this. Division would give you this, which reduces to 3/4. Next, we have this one. Now, the trick on this guy is first of all, we want to know that we're adding, right? So we would multiply these. But when you multiply this, you're multiplying this entire thing by 3. So it's like distribution. So it would be 3x plus 6. Okay? From there, then you would exponentiate. And so we would have 4 log base 4 of 3x plus 6 equals 4 squared. Those cancel. And from there, you just go ahead and solve what's left. Minus the 6 and divide by 3. You should end up with 10/3. All right, that's where we'll call it quits for today. We'll see you guys on Tuesday. Have a good weekend.